All right, welcome back to lesson 2 of week 7. So we're going to talk about multiple independent events. We're going to talk about a different way to kind of look at how we can figure out the probability of multiple independent events. Because what we did in the first lesson, we just looked at the probability of something happening multiple times. And now what we want to think about is something happening and then maybe not happening, or just different combinations of it happening and not happening. So we're going to go back to the coin flip example, and we're going to show how a tree diagram is going to help us to figure out the probability of different events. Okay, so the first thing we see here is it says, suppose you flip a coin once, what is the probability of getting heads? Well, if we want to use a tree diagram to figure that out, what we can do is we can say, all right, we're going to flip this coin, right? And there are two possibilities for flipping a coin. One is we get heads, and the other is we get tails. All right, and each one of those has the same probability, which is 1/2, right? So we know that the probability here is 1/2. We know that the probability here is 1/2. So if we flip that coin and we want to know what the probability is of getting heads, we would say, all right, I'm going to start here, whoops, and then I'm going to go here, and then I'm going to go here. So the probability of getting heads is 1/2, because we just followed the path from the coin to the option that was marked heads, right? So we know that the probability of getting heads is exactly 1/2. So we can just say 1/2. All right, now the way a tree diagram works, and the way a tree diagram is really helpful, is if we now want to know the probability of something happening more than once, or something happening and then not happening. So we're going to create a similar tree diagram. So we're going to be flipping that coin again, right? And we have a possibility of heads, but then we also have this possibility of tails down here. Okay, and so this one though says, suppose you flip a coin twice. And the way we can use a tree diagram to represent flipping a coin twice is what we just drew here. This is the first flip right here. Okay, so everything that is right here represents the first flip. All right, and then so after that first flip, we're either going to get heads or tails, right? And then we're going to flip the coin again. Well, if we got heads, we're going to flip it again, and we have the same possibilities, heads or tails, right? So if we get heads, we could get heads or tails again, right? Now, if we go down the other path and go down to tails, well, we could also get heads or tails again, right? So now you can see the tree diagram just basically outlines all the possibilities. And the second column that we created here represents the second time we flip the coin, right? So this is the second time we flip the coin here. So the green represents the first time we flip the coin. The orange represents the second time we flip the coin. Now, if we want to find the probability of getting both heads, what we have to do is just follow the path through the tree diagram where we get heads both times. So we're going to go up here, we get heads the first time, and we get heads the second time, and we can calculate the probability. Well, we need to put the probabilities in there to be able to calculate. And so the probability of flipping heads or tails is always 1/2. It doesn't matter. It doesn't matter if we flip the coin once or twice. The probability doesn't change, right? So we know this one is 1/2. We know this one is 1/2. This is 1/2 here. So each one of these is 1/2. So we can go ahead and fill in that probability. Now, if you wanted to, I suppose you wouldn't have to use a fraction. 1/2 is 50%, so you could put 50% in there if you wanted to. But the whole idea is we just follow the path and we look at it and say, hey, the first heads, there was a probability of 1/2. The second heads, there was a probability of 1/2. So the probability, I'll come down right here to do it, is just 1/2 times 1/2, or 1/4. Okay, so the probability of getting 2 heads is 1/4. Okay, so that's how we can use a tree diagram to be able to help us figure out the probabilities. So in that second tree diagram, you can see we just chose this path that went heads both times, right? So, but you could take all kinds of different paths through there. You could go heads first, tails second. You could go tails first, heads, and then, or tails, tails, right? So you have 4 different options for how you could actually go through this tree diagram. Okay, so let's go look at this example about a student who has a hard time waking up in the morning and shows up late to school. It shows from their attendance that they are on time 68% of the time. So the first thing that I'm going to do when I see a probability like that is I know that this means they're on time 68% of the time. So everywhere there's an on time in here, I'm going to write 68%. So I'm going to go, let's make that red just for fun. Okay, so every time there's an on time, I'm going to write 68%. Okay, so that means there, and even down here. Okay, and so then we have to fill in what the probability is if they're going to be late, right? And so remember, the probability of late is kind of like not in the previous lesson, the complement, right? So it's whatever we have to add to 68 to make 100%. And in this case, it's 32, right? So we can go ahead and fill in 32 for each one of the lates here. And every single one of them is going to get 32. It doesn't matter. It doesn't matter how many times we have to do it. We'll just fill in 32 for each late. Now, we've got our tree diagram built, so you can see we have a bunch of different paths we could take, and it's kind of like the heads or tails example. We have multiple paths that we can take through here, and same thing with the heads or tails. This first group of probabilities represents the first day. So this represents Monday, right? Because we want to know what's the probability of them being late on, or sorry, let me see here. Oh, we're going to ask a bunch of questions, but this is about Monday and Tuesday, right? So the gray that I shaded is Monday, and let's shade this another color here. Let's go with blue. And the blue that I'm shading here is Tuesday, okay? So we have Monday and Tuesday. And so we're going to be asked a bunch of questions about this now. So the first question says, what is the probability that the student will show up on time both Monday and Tuesday? So basically what we're going to do is we're just going to follow the path through the tree diagram for on time on both Monday and Tuesday. So I'm just going to go on time here and then on time here. So the probability is going to be 68% times 68%. So I can calculate that. And remember, when I calculate these, I want to use decimals instead of percents. So I'm going to just go ahead and change these to decimals and then go grab my calculator and do 0.68 times 0.68. And it's going to give me 0.462. All right, so I can go back over here and I can say 0.462, and then I'm going to move that decimal 2 places to get 46.2%. Okay, so there's a 46.2% chance that the student will be on time both Monday and Tuesday. All right, second question, what is the probability that the student will show up late on both Monday and Tuesday? Okay, so what we have to do now is say, all right, instead of following the path for on time, what we're going to do is we're going to follow the path for late. So we go down to late on Monday, and then we go down to late on Tuesday. Okay, so in this case, we have 32% times 32%. Okay, so you can kind of see how this works. We just follow whatever path we need to follow, and I can change these to decimals. And then I can go to my calculator and do 0.32 times 0.32, and it gives me 0.102. So I'll go back over to Notability, 0.102, and I end up with moving that decimal 2 places, so I end up with 10.2%. Okay, so there we go. We're working our way through these problems, just following the path that we need to take in order to figure out what the probability is. So the next one says, what is the probability that the student will show up on time Monday, but late on Tuesday? All right, so we're just going to go erase our path, and we're going to do a new path. So they're going to be on time on Monday, but then they're going to be late on Tuesday. Okay, so we just went a little bit different direction there. We went on time Monday, late on Tuesday. So we have to do 68% times 32%. And we make those decimals again. And we go over to our handy calculator, and we do 0.68 times 0.32. And we end up with 0.217. So we go back over here, and we say it's 0.217. Move the decimal 2 places, 21.7%. Okay. All right. Last question here. Now, the last question, I don't know if you noticed this, but if you look at the second question, it says, what is the probability that the student will show up late on both Monday and Tuesday? And this last question says, what is the probability that the student will show up late on Monday, but late on Tuesday? That doesn't make sense. I think what they meant here when they wrote this, it wasn't me, that it should say late on Monday, but on time on Tuesday. But anyway, we can just go with the way it's written, all right? And so if you look at the way it's written, it says late on Monday, late on Tuesday. So that means we're going to go to late here, and then we're going to go to late here. And you'll notice that we've already done that. It's already the second question. It's the same as the second question. It's just a different way to ask it. So we know we can just say, hey, it's the same as number 2. It's the same as 2, so it's 10.2%. Okay, so hopefully you can get the idea that with a tree diagram, you fill out your probabilities, and then you just follow whatever path that you need to take to go through and calculate the probabilities. Okay, so you've got a few to do on your own here. You have to enter these into Schoology, and I believe that you have to round them to the nearest 100th. Everything that we've done here has been rounded to the nearest 10th. So like 46.2 is a 10th, 10.2 is a 10th. So you're going to have one more number after the decimal. So you're going to have 2 numbers after the decimal in all of your answers. So you're going to have to be able to round those. And so when you enter them, you might not get them right the first time. Just go back and check your rounding, and you can have as many tries as you want to be able to get them right.